so the fundamental theorem of algebra, the most important theorem in all of algebra, says that if I have like x to the fifth, so my degree is 5, I'm going to have 5 zeros, counting multiplicity of the blinds.
Oh, okay.
That's a little loud. So if I have x to the fourth, I'm going to have 4 zeros. Now those could be repeated answers. Like I could have something like x minus 1 cubed. That would be 1 is answered 3 different times, right? It could have multiplicity, but that would mean there are 3 answers, right? 1 is an answer 3 times. So that's what the fundamental theorem of algebra says. So when I look at number 1, I see x to the fourth, so I know I'm going to have 4 solutions. So getting those solutions can happen various ways. Okay, so we could do factoring. We could do our P over Q, right, with our synthetic division and so on. In this case, it's easiest to factor. So we always try to factor first, especially like splitting the middle. We look for things like that. So if I have x to the fourth minus 1, do you guys all recognize that that's the difference of 2 squares? Okay, so when we factor, we're going to factor into x squared plus 1 times x squared minus 1. What do we see now? Yeah, so someone's saying I, because this is going to be x squared equals negative 1, which gives x equals plus or minus I. I agree. But what about this one? Doesn't this factor further? Yeah, it factors into x plus 1 and x minus 1. So its answers are negative 1 and 1. So its factored form is going to be f of x equals x squared plus 1 times x plus 1 times x minus 1. This would be what we call linear factors in irreducible quadratics. But if I say something like factored over the complex numbers, we could actually factor even further. So our fully factored form would be x plus I, x minus I, x plus 1, and x minus 1. Okay, I guess I didn't really say on this one. I should have said over the complex numbers, but that's fine. And our 4 solutions were 1, negative 1, I, and negative 1. Okay. So the next one, so it says f of x equals x to the fourth plus 8x. So it says use the quadratic formula to find complex roots 2. Okay, so it looks a little weird here. It's like, wait, how am I using quadratic formula yet? But let's go ahead and look at it. So if I factor it, I pull out the GCF of x. When I do, I get x cubed plus 8. Are y'all like, oh, aha. Yeah, x cubed plus 8. Do we remember how to factor this? We've done this a lot lately. All right, so try it. Do binomial and trinomial. So it's going to factor into x plus 2, x squared, 4 on the end, and in the middle we're going to have 2x. And if you remember, our signs are same as what we had before, opposite, and always positive. So we're going to do plus minus plus. Okay, like that. Did you all have that? So proud. All right, so now I start setting things equal to 0 and solving, and then we're like, oh, okay, I got x equals 0 from this first part. And then I have x equals negative 2. And we're like, oh, that's all the zeros. Well, not quite. That's all the real zeros, right? But we know since our original started out with x to the fourth, we should have 4 answers. And there are 2 additional answers from here. So that's when we use the quadratic formula. So you'll see me write QF a lot, quadratic formula. Your fave. So x equals negative b, which is 2, plus or minus the square root of b squared. So if I have negative 2 and I square it, I get 4 minus 4ac divided by 2a. So 2 plus or minus 4 minus 16 all over 2. So 2 plus or minus the square root of negative 12 over 2. Who thinks they can simplify that? What about the square root of negative 12? Yeah, Greta, what do you think?
2i.
Uh-huh. So we have 2 plus or minus 2i root 3 all over 2, which gives us, cheesy heart thing, take the 2 into everything, 1 plus or minus I root 3. Do we see that? We divided every single piece by 2. So our answers are 0, negative 2, 1 plus I root 3 and 1 minus I root 3. So we know that we have 4 solutions. So how about its factored form? It's a little weird. So if we have 0, we just have an x out front. You could put x minus 0 if you want to, but it's just x. The minus 2 is x plus 2. And then how about the other part? Yeah, what do you think?
X minus parentheses 1 plus or minus I root 3, and then the other one is the same, but it's 1 minus.
Yep, exactly. So we're going to have x minus, and then in parentheses we put each 0. So it's going to be x minus the first 0, and then x minus that second 0. Does that make sense? And if you want to distribute that negative in and clear out the inner parentheses, that's fine. Or you can just leave it like that. That's fine. I'll know what that means. Okay, that's its factored form. Isn't that weird? A little bit weird. All right, so the next one, number 3. I think this was on an Algebra 2 test last year. Many people missed it. So let's see if we know how to do it this time around. So it says, given that 1 and negative 2 are zeros, find the other zeros. All right, so if we know those are zeros, what should we do? Synthetic division, right? If we know they're zeros, that means it's going to factor evenly. We should do synthetic division to kind of break down that polynomial. So I'm going to put 1 in my synthetic division, and I'm going to make sure that I'm not missing anything. Am I missing anything? Yeah, I'm missing that 0x the 4th. So I'm going to write 1x the 5th, 0x the 4th, 1x cubed, 2x squared, negative 12x, and 8. So don't forget that 0. And we all know synthetic division, right? All right. So we factored into 1, 1, 2, 4, negative 8. So that's 1x the 4th plus 1x cubed plus 2x squared plus 4x minus 8. Okay, and we don't have to write that. We can just keep going because now we know that the next 0 is negative 2. So we cross out that remainder and we divide it again. So this means that our f of x that we had originally has now been factored a little bit so far, right? We factored it into x minus 1 because 1 was a 0, x plus 2, and then we have something left down there. Okay, so if I had x the 5th and I divided it twice by linear factors, what do I start out with? Yeah, Hallie? X cubed. So do you see anything special with this next part? Yeah. Can you guys tell that it's going to be a factor by grouping 1? Look at these numbers. Aren't these nice? 1, negative 1. 4, negative 4. If you pulled out a 4 from the second one, you would have 1, negative 1, right? So you can kind of see that factor by grouping coming together. So we're going to split down the middle. We're going to pull out the x squared from the first two. When we do, we have x minus 1. So we know that we have to pull out something in order to get the same thing, that x minus 1. And we pull out a number and a sign. So yeah, positive 4, right? So when we do that, we have x minus 1 times x squared plus 4. And we still have those ones from before, x minus 1 and x plus 2. So this is f of x. So this would be linear factors and an irreducible quadratic. Do we know where the irreducible quadratic is? Right here, right? Because you can't factor it further like our normal factoring, like you learned in Algebra 2. Okay, now notice the words that I used though. I said find the linear factorization. So that means that I want all of them to be what I call linear factors, like x the first. Right, so I'm gonna have to go down a little bit further. So what solutions does this one have? It's x equals plus or minus 2y. Are you guys really good at doing those now? Yeah, good. I love teaching pre-calc after I've taught Algebra 2 because it's like the things you didn't know in Algebra 2, all of a sudden it's like, oh, that's it. Like, yeah, that's it. So it's nice teaching a consecutive course. All right, so we have x minus 1, x plus 2, x minus 1, And then we're going to have x minus 2i times x plus 2i. That is the linear factorization. Make sense? Good. All right, next up. So number 4, so it says given 1 plus 3i is a 0, find all zeros of the function. So if we know that's a 0, we could do our synthetic division with i's. You guys didn't really like that, though. You can use your calculator to help you. Do you guys remember the synthetic division with i's? Wasn't there another way? Yeah, so if 1 plus 3i is a 0, we also have 1 minus 3i. So if both of those are zeros, that means I have x minus each of them in parentheses, right? So it's x minus the 1 plus 3i, and it's x minus the 1 minus 3i. Okay, so I want you guys to set this up so we can use long division. Do you guys remember how we did that last time? Okay, so I'm going to give you a second to try it. And then try that long division. See if you can do this. All right, so some of you guys got it and some of you are still having trouble. So if you're still having trouble, kind of pay attention to this first step. So we distribute the negative. So we have x minus 1 minus 3i and x minus 1 plus 3i. And then we're treating this x minus 1 as like a single term. So previously, that's when I was like writing it as w minus 3i times w plus 3i, so you could see it. When you FOIL that out, you'd have w squared minus 9i squared. All of the outer and inner terms would cancel. That's what we're doing here. So we're going to get x minus 1 squared minus 9i squared. Okay, and then the outer and inner stuff, like this times this, or the outer and then added to the inner, will go away. All of those i's. If you did it the long way, do you remember how you'd have like minus 3i plus 3i, minus blah, blah, blah. Like all those things with I will go away. All right, so we get to this point. So we have x squared minus 2x plus 1 when we FOIL that first part. You can do it off to the side if you need to. And then minus 9i squared, what's that? Plus 9. So I saw a lot of your papers had this, x squared minus 2x plus 10. Perfect. So that's what goes evenly into our polynomial. So if we do our long division with that, so x to the 4th minus 2x cubed plus 5x squared plus 10x minus 50, we're going to go ahead and we're going to say, what do we multiply x squared by in order to get x to the 4th? And we do our long division now. So we're like, oh, it's going to be x squared. And then we take our x squared times everything in the divisor, and we go through our long division steps. So we get x to the 4th minus 2x cubed plus 10x squared. Draw the line, change the signs. Add straight down. X to the 4ths go away, x to the 3rds go away, and then we have negative 5x squared. And in this case, we drop 2 terms. Does that make sense? Because the next line, we're going to have 3 terms. And we go one more time. So we say, what do we multiply x squared by in order to get negative 5x squared? So we need a negative 5. So I saw positive 5 on a couple of your papers, so make sure we have negative 5. And then we take that negative 5 times everything, negative 5x squared plus 10x minus 50. So when we draw the line and change the signs, everything goes away. So our remainder is 0. Shouldn't our remainder be 0? Yeah, if your remainder is not 0, you did something wrong. So that means that we've factored into f of x equals, and we had that part that was x squared minus 2x plus 10, and then we had the part that was x squared minus 5, right? So what are our solutions when we have x squared minus 5? Yeah, exactly. We get x equals plus or minus the square root of 5. So if I asked for irreducible quadratics, it would look like this, right? Those were irreducible without using i's and square roots, right? Over the reals, we would say. Irreducible quadratics over the reals. But if I think on this one, it's just asking for the solutions. So when we talk about all of the zeros, we should have 1 plus 3i, 1 minus 3i, square root of 5, and negative square root of 5. Those are all of our zeros. So if I asked for the linear factorization or factored over the complex numbers, it would be like x minus each of those. It would be the final factored form. Does that make sense? It's like weird what books will ask for. All right, so last couple here. So it says write a polynomial with real coefficients that has a 0 of 3 minus 2i. So it says, hint, if 3 minus 2i is a 0, then 3 plus 2i is also a 0. So all we're asking for is, like, if we were doing like our long division, what's that part that's on the outside, just like we just did. So we're saying, well, I have x minus the first 0, and I have x minus the second 0. So let's go ahead and find this polynomial. Second chance, you guys want to try this? So try it along with me. Don't look up here until you're really stuck. All right, did you guys get x squared minus 6x plus 13? All right, so that's your function or polynomial. So you can say p of x, f of x, whatever you want it equal to. Okay, does anybody have questions on that, or did anybody get stuck somewhere in the middle? Do we feel more comfortable with that? Okay. And then number 7 says use the shortcut to write the quadratic function with zeros of -2 plus I and -2 minus I. I mean, I'm doing the shortcut, so we just did it, didn't we? But same idea. So it'd be like x minus -2 plus I and x minus -2 minus I. So you'd have x plus 2 minus I and x plus 2 plus I. So again, we're grouping the x plus 2's together, and then we're doing our FOIL with x plus 2 as a single term. So we're saying, okay, I have x plus 2 quantity squared minus I squared. Can you guys do the x plus 2 squared in your head, or do you have to write it off to the side? I had to write it off to the side, even when I was in AP Calc. I don't know why, I just could not do it in my head. So if you have to write it off to the side, it's fine. X squared plus 4x plus 4, and then plus 1 from the minus I squared. So we get x squared plus 4x plus 5. That's our quadratic function with those zeros. Okay. Easy enough? Can you do that? All right.